Hi everybody. Alright, so we're going to start the second unit. Hopefully this one doesn't take nearly as long as the first one. We'll see how it goes. Here we go. Classify each pair below as corresponding alternate interior, alternate exterior, same side interior, vertical angles, linear pair, or none of these. Okay. So 7 and 10. The best thing to do when you're solving, when you're doing a problem like this, if there's two pairs of lines that are crossing, or intersecting rather, block the line that doesn't matter. This line over here doesn't matter for 7 and 10. So 7 and 10 are corresponding. It's a lot easier if you limit how much your brain's processing. 7 and 8, okay, those are vertical. 7 and 6, okay, I actually rotated as well because I like the interior to look like the interior to me. For some reason it's easier for my brain to process. These are alternate interior. 8 and 9, we're going to call those, well, they're adjacent, and they're a linear pair. So, linear pair. 4 and 7, these are alternate exterior. If M is parallel to, let me zoom in so you can see that a little better. If M is parallel to N and P is parallel to Q, so I assume we're talking about these, and the measure of angle 9 is 78 degrees, what is the measure of angle 2? Okay, so, alright, so we are talking about these, making sure. So I'm going to fill these in. So measure of angle 9 is 78 degrees. We're told these are parallel, so I'm going to mark these to show they're parallel. We're looking for this angle here. Okay. Well, there's a few ways for us to get there. So we know that this angle 9 corresponds to this angle here, so that means this is 78 degrees. And there's a bunch of ways you could do this. This is just the way I'm going to do it. And we know this is a linear pair, so we know this would be 102 degrees. And we know 10 and 2 correspond, so therefore this is 102 degrees. But there's a bunch of ways you could go from 9 to 2. That's just the way I chose to go. Okay. All right, if M is parallel to N, find the value of the variables and the numbered angles. Okay. So we know these are alternate exterior, and we're told these are parallel, so because they're alternate exterior, they're going to be congruent. So 112 equals 18x plus 4. Subtract 4 from both sides. This would be 108 equals 18x. Divide both sides by 18. So 108 divide by 18 equals 6. X equals 6. I'm assuming that's all we have to do for that one, I think. Yeah. All right, over here we got, let's see, these are alternate interior, so they're going to be congruent as well. So 113 equals 16x plus 2. Subtract 2 from both sides. So we have 111 equals 16x. Divide both sides by our coefficient, which is 16. So 111 divided by 16. Okay, we're going to get a fraction. I don't know why they did that. Not a great example. We're actually going to leave that as an improper fraction. It's 16 point, yeah, we'll just leave it like that. I don't really care. Or 6 and, let's see. Yeah, I don't really. Hold on a second. 6 and 16 times 6. 4. So we're going to get 6 and, let's see, 4, 15 sixteenths. All right, that's interesting. Okay. So over here, these are corresponding. They're going to be the same because these lines are parallel. So 5 plus 10x equals 75. Divide, we'll just have to divide. We're going to subtract 5 from both sides. This is more like it. 10x equals 70. Divide both sides by 10. X is going to be equal to 7. Okay. Here, these are same side interiors, so they're going to be supplementary. So 75 plus 18x minus 3 equals 180. These are a little different. Combine like terms, so 75 minus 3 is going to be 72 plus 18x equals 180. So subtract 72 from both sides. 108. Divide both sides by 18. That's going to be 6. Okay, last one over here on this page. Let's see. So these are vertical, which means they're going to be congruent. So 14x equals 13x plus 5. Subtract 13x from both sides. And x will equal 5. Okay. Let me zoom out here so you can see a little better. Okay, line M and N are parallel lines intersected by a transversal line L, as shown below. Which of the following pairs of angles must have the same measure? Okay, so let's see. 1 and 8 do not need to be the same. 2 and 6 do need to be the same because they're alternate interior. 6 and 7 do not because they're same side interior. 8 and 5 do not because they have no particular relationship. Okay. Find x so D is parallel to F. So these are corresponding, which means if they were parallel, they'd have to be congruent. So we're going to write 3x plus 11 equals 47. We're going to subtract 11 from both sides. So 3x equals 36. We'll divide both sides by our coefficient, which is 3. X will be equal to 12. All right. Line W is represented by this equation. Which of the following equations represents a line that is perpendicular to line W? So perpendicular means they're going to have the opposite inverse for their rate of change, or slope. So the rate of change here, or slope, is 3, because this is in slope-intercept form, so we're looking for negative 1/3. It has to be this one. Okay, what is the equation of the line between points negative 3, 2 and negative 4, negative 3? You may leave your answer slope-intercept form. Okay, so they give us 2 points, and we need to write this. We need to write in slope-intercept form. So we're going to use 2 equations here, or 2 formulas rather. First, we're going to do m equals y2 minus y1 over x2 minus x1, because we need to calculate the rate of change. We're going to see our x1, y1, and our x2, y2. Right here. So negative 3 minus 2 over negative 4 minus negative 3. Be careful, there's double negative here. And that's going to change into plus. So negative 3 minus 2 is negative 5, and then negative 4 plus 3. And negative 4 plus 3 is negative 1. So negative 5 over negative 1 is 5. So our rate of change is 5. So we're going to use the point slope form because we have one of the points and the slope. So y minus y1 equals m parentheses x minus x1. So y minus, our y1 is 2 equals m, which is 5 over here, and then x minus x1, which is negative 3. So x minus negative 3. And again, that's going to become plus 3. So let's rewrite that. Y minus 2 equals 5x plus 3. And we're going to distribute that 5. So y minus 2 equals 5x plus 15. And again, we want to get to be slope-intercept form, so we want to get this y by itself. So we're going to add 2 to both sides. And y will equal 5x plus 17. And that's it. So y equals 5x plus 17. Okay. Which of the following statements is always true when parallel lines are cut by a transversal? Okay, so let's just draw that, just so we can kind of have a visual, right? So these are parallel, it says. The sum of the degrees sum of the degree measure of corresponding angles is 180. So when you add two corresponding angles together, it has to be equal 180. That's not necessarily the case. The sum of, let's cross that out. The sum of the degree measure of complementary angles is 180. Nope, that'll never be the case. Complementary angles up to 90. The angles in a vertical pair are acute. No, not necessarily. Corresponding angles are supplementary. I mean, they can be, but they don't need to be. Corresponding angles are congruent. Yes, they'd have to be if the line's parallel. So it's E. Line K is represented by this equation. Which of the following equations represents a line that's parallel to it? So parallel lines have the same rate of change or same slope. So we're looking for a line that has -5 as its rate of change. Has to be B. Which of the following represents a line that is parallel to y equals 4x minus 8? So, okay, we're looking for a line that has a rate of change of 4. However, none of these are in slope-intercept form. They're all in standard form. So what we need to do is get them in slope-intercept form. So that's fine. We'll start with, let's see. We'll start with D, because I'm gonna cheat. I don't feel like doing all of them. So 4x minus y equals -5. Again, we want to get y by itself, so we're going to subtract 4x from both sides. So -y equals -4x minus 5. And we're going to divide both sides by -1. And y will be equal to 4x plus 5. And that is parallel to it, so it's going to be this one right here. Okay, find an equation for the perpendicular bisector of the line segment whose endpoints are -8, -3, 2, 3. Okay, so this is an interesting problem. So first we need to find the midpoint of this, because that's the bisector and cut it in half. So we use these 2 points to find the midpoint. Okay. So this is x1 and y1, and this is x2 and y2. Okay. So x1 plus x2 over 2, and y1 plus y2 over 2. So we have -8 plus 2 over 2, and -3 plus 3 over 2. So -8 plus 2 is -6 over 2, which is -3. And -3 plus 3 is 0, and 0 over 2 is 0. So -3, 0 are the coordinates of the point going through it. So let's go ahead and just draw this. I think it'll be easier if we do that. Okay, so we have -8, -3. Again, this is not drawn the way it would look, just to give us a visual here. 2, 3, and the midpoint is going to be -3, 0. Okay. Okay, we have that. Find the equation for the perpendicular bisector. So now we need to know, we need to go perpendicular to this line. So this line would need to be perpendicular to that, so we need to calculate the rate of change for these 2 points. Well, yeah, it's kind of a mean problem. It's not super complicated, but it's kind of mean. We put that out there. It's kind of a mean problem. All right, so, all right, let's find the slope of the line segment first. So rate of change is going to be y2 minus y1 over x2 minus x1. And that's going to be these 2 endpoints here. So we're calculating the rate of change. So, okay. -8, -3 will be our x1, y1. x1, y1. And 2, 3 will be our x2, y2. So m is going to be equal to 3 minus -3. And x2 is going to be 2 minus -8. So these are both going to change. So 3 plus 3 over 2 plus 8, which is going to be 6 over 10, which is 3 over 5. Okay, so the rate of change of this is 3 over 5. This would be perpendicular to it, which means we're going to take the opposite inverse of 3 over 5. So we're going to flip it and change its sign. So the m we're going to use is going to be -5 over 3. Okay, so that's -5 over 3. The point is -3, 0. So we have our point, we have our slope. We're now going to use point slope form. So we're going to use y minus y1 equals m parentheses x minus x1. So y minus 0 equals negative 5 over 3, parentheses, x minus negative 3. Okay. So y minus 0 is y, negative 5 thirds, and then x plus 3. We're going to distribute this negative 5 thirds. Y equals negative 5 thirds x. And the negative 5 thirds times 3 is going to just be negative 5. So that would be the equation of the line that is perpendicular and bisecting this. Wow, that's kind of intense, not going to lie. Okay, so y equals negative 5 thirds x minus 5. There's one more page? Yeah, okay. All right. Moving right along. Okay, so what is an equation of the line that passes through point 1, negative 3 and is parallel to this line? Okay, so we have the point. We don't have the slope because this is in standard form, so we need to get this in the slope-intercept. Oh, sorry, this one right here. We need to get this in slope-intercept form. So that's the first thing we're going to do. So 4x plus y equals 4. Let's get y by itself. So we're going to subtract 4x from both sides. So y equals negative 4x plus 4. So it's parallel to this, so it has the same slope, which means we're going to use m of negative 4, because that's our rate of change. And that's the point. That's going to be our x1, y1. So let's go ahead and use this. Use some scrap paper here. Okay. So y minus y1 equals m parentheses x minus x1. Y minus negative 3 equals negative 4 x minus 1. This is going to change to plus. And distribute this negative 4. So y plus 3 equals negative 4x plus 4. I'm going to subtract 3 from both sides. Y equals negative 4x plus 1. And that's it. Y equals negative 4x plus 1. Okay, what is the equation of the line that passes through this point? So this is very similar. It's almost identical. The only difference is we're going to get y by itself here, and then take the slope and flip it and change its sign because it's perpendicular. So let's do that. So x plus 6y equals 6. We're going to subtract x from both sides. So we have 6y equals negative x plus 6. And then divide everything by 6. And y equals, now negative x over 6, we're going to change that to negative 1/6 x. And this is 1. Now that's something some students struggle with, changing this to that. Same thing, but we're writing it in a way that will allow us to identify the rate of change, which is in this case negative 1/6. Now, the line we're looking for is perpendicular to this line, so we're going to take this slope, we're going to flip it and change its sign. So we're going to use m equals positive 6 over 1, it's positive 6. Our point is 2, 8. And let's do it right here. So y minus y1 equals m parentheses x minus x1. And let's plug in our values here. So y minus 8 equals 6 parentheses x minus 2. Let's go ahead and distribute the 6. Y minus 8 equals 6x minus 12. We're going to add 8 to both sides. Y equals 6x minus 4. And that's it. Okay, last one. Here we go. So we got Miss Ferreira, legend status right there, by the way. Miss Ferreira drew the line represented the following equation on a coordinate plane. All right, so she's got the slope-intercept form here. Miss Cardy, not to be outdone here, on the same coordinate plane, Miss Cardy drew a line that is perpendicular to the original line and passes through the point negative 4, negative 3. If Miss Cardy wrote hers correctly, what is the equation of her line? Okay, so we got Miss Ferreira's line right here. Miss Cardy drew a line that's perpendicular to this one and goes to this point. So if it's perpendicular, we need to take this rate of change, flip it, and change its sign, because it's the opposite inverse. So 2/3 will become 3 over 2, and a positive will become negative. So our rate of change is going to be negative 3 over 2. And it's going through the point -4, -3. Now there's not a lot of room here, so we're going to use another piece of scrap paper here just to figure this out. So this will be Miss Carty's line. So we have y minus y1 equals m parentheses x minus x1. Y minus, in this case, would be -3. Y minus -3 equals m -3 over 2. X minus -4. Excuse me. So y plus 3 equals -3 over 2, and x plus 4. Okay, let's distribute this right here. Y plus 3 equals -3 over 2, x, and then -3 over 2 times 4, let's see, 2, -6. Okay, and then we're going to subtract 3 from both sides. So y equals -3 over 2x minus 9. And that's it. That's the equation of Miss Carty's line there. All right, well done, Miss Carty. Y equals -3 over 2x minus 9. Okay. Mr. Edwards, who's that guy? Yeah. Mr. Edwards wants to write the equation of a line parallel to the original line and for it to also pass through point -4, -3. If Mr. Edwards does his work correctly, that's a big if. What is the equation of the line? All right, so let's see. All right, so it's parallel to the original line. So the original line is Ms. Ferrer's, right? So it's going to be parallel to this. So we're going to have a rate of change of 2/3. It's going through the point -4, -3. Okay, so -4, -3. So that's our x1, y1. We have our m. We're going to use point slope. You can see we're using point slope a lot. It's m parentheses x minus x1. Okay. Y minus -3 equals 2/3 x minus -4. I'm going to change these to plus. Y plus 3 equals 2/3 x plus 4. I'm going to distribute this. Y plus 3 equals 2/3 x. Okay. And then 8/3, which is going to be, let's simplify that, y plus 3 equals, let's change that to a mixed number, 2/3 x. 8 over 3 is going to be what? That's going to be 2 2/3, I think. Yeah, okay, I think that's right. And then we're going to get y by itself, so we're going to subtract 3 from both sides. Leave it to Mr. Edwards to have a fraction for the y-intercept, huh? Oh, tricky Mr. Edwards. All right, so y equals 2/3 x. 2 2/3 minus 3, that's going to be -1/3. Take my advice on that one. I guess we're getting free advertising from Federal. Oh well. That's it. Okay, so that's the Unit 2 review. That was much quicker than the Unit 1. I'm going to try to get Units 3 and 4 done today for you guys as well. Let me know if you have any questions. All right, thanks.